Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So this is the subject of the idea of negative motion, that you can have a collision or an event and the energy that goes this way is believed to cancel the energy this way, that you subtract them and the net product will somehow be the energy that caused the event. Which, in my opinion, makes no sense at all, of course, because obviously the energy is something possessed, like currency, and I can't have $10 and then make $15 go that way and $5 go that way and pretend I caused the event, because it doesn't make any sense. I have $20, I can't have 20. So this is basically the outline of the experiment that physics says they have done, successfully accomplished it. They used air tracks and they used the cars with the little metal wheels, and say that they make this happen. So you have 100 momentums, okay, you could call that 10 joules in, okay, and so it's on it. Let's say you use a pendulum. You'll get the energy back in the sense that 50 will come back this way and 150 will go this way if it's a 3 mass. So we're talking about this is a 3 mass and that's a 1 mass. And this is what they say actually happens, that you create more motion in the direction, more momentum in the direction that you're pushing the force. So if it was a car, it's a 1 mass car, it's going, let's say, whatever, 100 momentums, and it makes 150 in the heavier car. So the heavier car is going a little slower, but it has this increase in its momentum. Yeah, just as words that should bother you. Free momentum, that doesn't sound right. And it's their claim that this 50 somehow undoes 50 here, and you only have a real 100. Even though if this was a closed system and these objects weren't on strings, they would hit the outside walls of your closed system and be producing 200 worth of pressure. So there's no fact that says it isn't 200. I only put 100 in, and now I have 200 units of pressure in my system. Well, anyway, so if we are using pendulums, though, we can make the energy come back together again, and their claim is that only 100 pops out. So now I have 200 momentums in a collision, and somehow only 100 momentums pops out. And this repeats. And they think this is a reasonable position, a reasonable argument, a reasonable model of reality. So there's so many, it's, you know, all these arguments you're saying, well, how can I demonstrate that this is impossible? Because I could just do this a second time and a third time, and I ended up starting with 100 momentums and ending up with 500 momentums. And how can that make any sense? Because you sort of know from the bowling example that momentum knocks pins down. Objects hit and they share their momentum with the objects they hit, just like pool balls. So the argument is I'm going to move more pool balls with the added energy I have going in the same direction that my energy was going in. And that can't happen because I can't make free motion. I can't make a free disturbance in the universe. I can only follow energy. I can't make it. And momentum, even if you don't think it's officially energy, it behaves just like it was energy. You have to conserve it. You can't make more of it, and you can't destroy it. You can't have 200 going in and only get 100 out. So I would argue that this is something that could realistically happen. That, you know, if you bet $1 million on a bowling experiment, you could actually use the same principle, because you could have a bowling ball that only has 100 momentum. That's the force you push with, 100. And you now have 150 smash into the pins. And the catch is you get 50 back. So that ball leaves and this next ball goes in, and now your pendulum is going to hit a new ball, All right, and it's going to hit it with 50, but it's going to add half that value, so it's going to be going 75 more momentums for the second ball, and I'm going to get 25 back. That's the deal. Okay, so now I'm going to hit the next ball with 25, and then I'm going to add half of that 25 to it and end up with 37, right? And we'll probably end there. But that's how much. So I've gotten 150, that's 225, that's 250 something. No, it's obvious, yeah, 250 something. So I've increased the total momentum by more than twice, and sent 3 things to knock pins down that will exchange momentum. So obviously it's going to be a sure thing that I'm going to get a strike every time. So it just doesn't make any sense. And I can make it even worse by making this, instead of a 3 mass by their theory, if I use something like a 10 mass, I can get maybe 200 momentums on the first hit and get 100 back, and get a whole lot more energy into the system, because I'll get not 100 but say 90 back, and then I'll hit it with 90, and then I'll get another 170. So I could probably get up to at least 1,000 joules. So I can start with, well, what we said was 10 joules, and I can end up with 100 joules or 200 joules worth of energy just by hitting light things into heavy things and somehow making free momentum, extra momentum in a direction. So again, their theory is that somehow when an explosion goes off, okay, that the fact that it's equal energy in both directions means that the energy all cancels. So you just cancel all the vectors and say the explosion had 0 momentum. It didn't exchange any momentum with anything. It didn't affect anything with momentum, because somehow it doesn't have any momentum, because it's somehow all canceled, or the energy canceled. And obviously anybody who's seen an explosion knows that there's not 0 energy in the explosion. Another argument I've already used, but is the simple idea that you could have a bunch of pool balls, and you could hit them with a cue ball. You're applying a certain fixed amount of momentum again, and the fact is there's going to be lots of cue balls that are going to leave in opposite directions, and by their theory all of that energy has to be canceled, and that if I'm going to conserve the momentum, it means the only things going in the same direction that I started with will be part of the equation, and anything going in the opposite direction certainly would cancel part of that energy. And somehow they think I will conserve the momentum even though I canceled a bunch of the motion of the balls. Now, I'd say anybody who's played pool, or anybody who's been awake and not drunk on Earth, I think, knows that the only thing I can do is I start with 100 momentums. All of these balls counted together add up to 100. All of the masses moving is the same as the momentum I hit with. So whatever this ball had, that's the total I have to have. I can't cancel any of it. If any of it cancels, I'm not going to conserve the momentum. So obviously this idea that there's such a thing as unenergy, or unmotion, or anti-motion doesn't work. And obviously it's in the form of anti-momentum. Because that's all they're saying cancels is momentum, and then you're left with the total energy. And again, it doesn't happen in the real world, and if it did happen that you could make this extra momentum, somebody'd be capitalizing on it, I'm sure, because extra momentum is extra energy. Extra momentum makes more heat. Extra momentum can be converted into more heat. It can be converted into something we can use in terms of making something we want to have happen. We can do more work with more momentum. So it's really, it's, I would argue it's paradoxically silly, okay, and yet they firmly believe it. I mean, so arrogantly and obnoxiously. And they say, they do these little air track experiments where, in the classic case that I have shown is Professor Lewin, because he has a very high quality air track, $10,000 air track, and apparently it works really well. And so the only way they can make this experiment happen, where they can hit a one mass cart into a two mass cart, okay, and we'll say again it's 100 velocity for this, 100 momentums, and it will make this cart leave, okay, with 133. See, the higher the difference, so this is 1 to 2, they don't do 1 to 3, and they don't do 1 to 5, and they don't do 1 to 7, and they don't do any of those higher experiments because it would get even more ludicrous. But anyway, so he did the experiment, and he, created these results with his air track. But if you look at his cart, there's a big blob of clay on the one cart, and then when you look at the cart that's supposed to weigh twice as much, it doesn't have twice the amount of clay on it, doesn't have any clay on it, and it only has the same amount of weights on it. And so there's good reason to believe it can't possibly be twice as heavy. So later in the same lecture, he does the experiment intending to do a it sticks experiment, okay, where, physics and I agree on what's going to happen and that the momentum is going to be shared between the two masses. And the fact is it doesn't stick. So it ends up being a duplicate of this experiment, but these carts are better, cleaner. Okay, they don't have balls of clay scraped up and put on them. And the fact is when he does the experiment and the Velcro doesn't stick, the numbers come out for momentum. Only 75 momentums here and 25 over here. So you end up with the same momentum you started with. So it gives some reason to doubt that their physics is as well done as they would like to claim it to be, that it has all this integrity, that it's all been well tested, and that they aren't doing just performance art. They aren't trying to just show an experiment instead of reveal an experiment. They're not testing it, they're demonstrating it. They're forcing it to come out the way the book says it should come out. They're not allowing it to naturally come out that way. So there's one more example that I should probably say for a separate video. I don't know if I can erase this. You almost can. Yeah, almost. I can explain it. So you take a steel anvil, and you could take another pendulum, and you could just bounce the one mass against the steel, and it'll just keep bouncing, 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 and you might be able to get it to bounce hundreds of times, literally, if the steel is hard and the object you're using is very elastic, glass or something. And they're claiming that every time it hits, it puts the same energy, twice the energy, into the anvil. And you can understand the anvil's not going to move, and that if you put twice the energy in, that means you have gotten all your energy back going this way, and you have twice as much energy going that way. So that's even more of a ludicrous free energy experiment, in the sense that now you put 100 in and you get 300 out, and the fact that you got all your energy back means you could just let it keep happening over and over again. So you were talking about thousands of times more energy going into the anvil, when the simple explanation is, no, the energy just reflected. That's you put 100 motions in, and you got 100 motions going out. And so just like a lever, it just changed the direction. You can put something in this side of the lever, and you can have something leave the lever this way, right? So changing direction isn't miraculous. And if something bounces off of a surface, it's an indication that the direction was changed, and there isn't any energy going in both directions. You're just getting the energy you put in, it's just reflecting, like light reflecting off a mirror or something. Alright, that's enough. A little longer than the average video. But it doesn't make any sense. I don't know why people are so glued to something that has such obvious paradoxical elements to it. But again, they're very aggressive in saying this does happen. Negative motion, anti-motion, unmotion happens. And it doesn't.